Assalamu alaikum. Myself Dr. Ansari Farzana Zama, Department of Chemistry, J.A.T. Arts, Science and Commerce College for Women, Malegaon. Welcome all of you. In the previous presentation, we have seen about diffraction grating, prism and detector. And also we have seen about in detail the photovoltaic cell. There is certain characteristic of photovoltaic cell. It is completely different in design and principle of photoemissive cell and works without use of battery. These cells generate their own EMF. The magnitude of photocurrent is directly proportional to the radiant power of incident radiation striking on it. The cells are sensitive over whole visible region. The typical cell has maximum sensitivity at about 550 nanometer. The current output of the cell depends upon the wavelength of incident radiation. Disadvantages of the photovoltaic cell. The current produced by the cell cannot be readily amplified because of low internal resistance. The cell show fatigue effect, that means its current output decreases slowly during continued illumination. The fatigue effect can be minimized by careful selection of optimum level of illumination. Due to the above mentioned characteristic and disadvantages, these cells are not used in sophisticated spectrophotometer. However, these are installed in inexpensive filter photometer. This is simple. A second detector, it is called as phototube. The cell is also known as photoemissive tube. It consists of an evacuated glass bulb. Inside the bulb, there is a photoemissive cathode in the form of half cylinder of metal. The inner surface of cathode is coated with the light sensitive material such as oxide of cesium or potassium or silver. A metal ring is inserted in the bulb, acts as an anode. A high voltage is impressed between the anode and cathode. When light falls on the cathode, the electrons are emitted by the cathode due to photoelectric effect. The liberated electrons are attracted to anode, causing an electric current to flow through the external circuit. Due to flow of these electrons, there occurs an IR drop across the resistance RL, which is proportional to the current. The current is amplified and measured by the readout device. The current measures to radiant power of light radiation striking the photosensitive surface. The sensitivity of phototube to wavelength of incident light vary with photoemissive material used in tube. By changing this material, tube sensitivity to various regions of the spectrum from the UV to near IR can be obtained. Phototubes are more sensitive than photovoltaic cell. Now, third type of detector is called as photomultiplier tube. It contains a photoemissive surface as well as many other surfaces that emit a cascade of electrons from photoemissive area. It is more sensitive than phototube for visible and ultraviolet region. It is mostly used in spectrophotometer. A photomultiplier tube consists of cathode and anode and many additional electrodes that are called diode. All these are enclosed in an evacuated glass bulb. A photoemissive cathode is the form of half cylinder of metal. So this is called as simple. These are diode. This inner surface of cathode is coated with light sensitive material such as oxides of cesium or potassium or silver. Most photomultiplier tubes have 9 diodes. A diode is an electrode with coating of cesium which emits several electrons, 2 to 5 electrons for each electron is tracking on its surface. When the light radiation strikes the cathode surface, it ejects electron due to photoelectric effect. This primary electron gets accelerated in the electrostatic field between the cathode and the first diode and falls on diode first. This first diode is at 75 to 100 volt more say positive than cathode. When electron strikes on diode first, each electron causes emission of several electrons. These secondary electrons in turns are accelerated towards diode second, which is at 75 to 100 volt more positive than diode first. At diode second, again each striking electrode cause emission of several electrons. This process is repeated 9 times, where each secondary electron release several electrons in the process of repeated 9 times. Nearly 10 raised to 6 to 10 raised to 7 electrons have been released for each photon striking on the photocathode. Finally, electrons leave the last diode and are received by the anode. The resulting current is then amplified and measured by readout device. The magnitude of current is proportional to radiant power of radiation that strikes on photocathode. The overall amplification factor is about 10 raised to 6. A photomultiplier tube must carefully shield it from stray light. These are the simple advantages of photomultiplier tube. Now, application of calorimeter. There are numerous application of calorimeter, particularly in quantitative analysis, in the elucidation of structure of organic compound, and in inorganic complexes. These applications are discussed in detail. Quantitative analysis. The calorimetric quantitative analysis is basically due to the Beer's law. In short, analysis is based upon absorption of light radiation by absorbing material in solution, and the amount of light radiation absorbed is directly proportional to concentration of absorbing species in the solution. Now, quantitative analysis first method, unknown concentration by first method, that means by calibration curve method. This is due to This is done by construction of calibration curve as per Beer's law. The curve is constructed by preparing series of solution of known concentration. The calorimeter is set a wavelength where the absorption of this standard solution is maximum, that means lambda max. After this, the absorbance of each of these standard solution is determined by referring the solvent in which the solution is prepared. As a blank for adjusting 100% transmittance or zero absorbance, the absorbance are then plotted against concentration of solution. A best straight line is obtained and the curve thus constructed is called calibration curve. The slope value of line is epsilon b. See in this figure, then the solution of unknown concentration is treated in the same way and its absorbance is determined using same Q.A.T. and wavelength, knowing the absorbance of unknown. Its concentration is determined with the help of calibration curve, which is shown in this figure. Then unknown concentration by method 2. Alternatively, the unknown concentration can be determined without constructing calibration curve. From Beer's law, we can state A1 is equal to A1 B1 C1, or this is equal to epsilon 1 B1 C1, or A2 is equal to A2 B2 C2 is equal to epsilon 2 B2 C2. Since the absorbing spaces in both are same, therefore A1 is equal to A2 or epsilon 1 is equal to epsilon 2, and because Q.A.T. used in both determination are identical, therefore B1 is equal to B2. The condition of ratio of above relation is that C1 upon C2 is equal to A1 upon A2, or C2 is equal to C1. Slightly rearranging this equation, C2 is equal to C1 into A2 upon A1. With the help of this equation, you can determine the concentration of unknown sample. Unknown concentration can be determined with the help of another method. That means the unknown concentration can be easily determined with the help of spectrophotometer and Beer's law. With the help of example, A is equal to log of P0 upon P is equal to log of 1 upon T ABC. In spectrophotometry, the path length is constant for a given pair of matched Q.A.T. and the radiant power of incident light is kept constant under this condition for given system and set up the instrument A and or AB and Pi are constant. Thus, we get direct relation between log and C. The radiant power of transmitted light of unknown is determined and the concentration is calculated by the relation C is equal to log of P0 upon P upon AB. Determination of unknown concentration of iron by Thiona cyanide method. It can be determined with the help of this equation. Now, unknown concentration of iron third by thiocyanide method can be determined with the help of spectrophotometer or calorimeter. This is the simple procedure for preparation of the solution. This one is also preparation of blank solution. And then after determination, plot a graph of absorbance against concentration of the solution. that means optical density against C, and with the help of Beer's relation you can determine the concentration of iron third. Thanks for watching.